At 4 o'clock on November 3, 1943, Lieutenant Dwight Claflin stood in the frozen rail yard outside Novelski Depot with grease on his hands and nothing to show for 14 patrols. 29 years old, 14 security runs through German-held forest, 0 confirmed kills. Around him, the yard was a graveyard. 17 T-34 tanks sat dead in the Siberian mud, hulls cracked, engines seized, tracks blown off their sprockets by Panzerfaust teams and German 88mm fire. The Red Army's armored branch had already written them off. Parts had been stripped, paperwork had been filed. The machines were officially scrap. Claflin walked between them in the pre-dawn dark, boots crunching on frost-stiffened gravel, and he did what he always did when command gave him nothing. He counted. 17 dead tanks, 17 76mm F-34 main guns. But 17 turrets, each one weighing just over 3,900 pounds, each one still fully intact, each one capable of firing a high-explosive shell at 680 meters per second, with enough force to punch through 90 millimeters of rolled steel armor at point-blank range. The tanks couldn't move, but their stings were still very much alive. 200 meters away, 3 low-profile flatbed rail cars sat on a maintenance siding. Each one was 6 meters long, 2.1 meters wide, and rated for 12 metric tons of cargo. The Soviet rail network stretched 1,400 kilometers behind the front line. The Germans had no record of these cars. They weren't armored trains. They weren't marked. They weren't anything. By mid-November 1943, German tank hunter Jagdkommando teams had destroyed 11 Soviet supply convoys along the Novelski corridor. The pattern was straightforward. So Soviet trucks moved at night. German scout teams radioed coordinates. German Panzers and SD-KFZ half-tracks hit the column from the tree line. The trucks burned. The supplies never arrived. 3 Soviet rifle divisions were now running on half rations and borrowed ammunition. High Command's answer had been armored trains, massive, purpose-built iron fortresses running on dedicated rail lines. The problem was mathematics. The nearest functioning armored train was 340 kilometers east. It required a crew of 30, a dedicated locomotive, and a rail line rated for 280 tons of rolling weight. The Novelski siding was a secondary branch line. It was rated for 40 tons. The standard armored train would collapse the rail before it fired a single shot. Claflin's commanding officer, Colonel Petrov, had assigned him to Novelski as punishment, a dead-end rail security detail for a tanker who couldn't produce kills. The assignment came with 4 men, 1 radio, and no armor. What it also came with, by accident, was Hagler Norwood. Norwood was the depot's chief repair mechanic, a square-shouldered man with permanently blackened hands and welder's goggles perpetually pushed up onto his forehead, where they left a red ring across his brow like a second set of eyes. He had been welding Soviet armor since 1941 and had a mechanic's contempt for anything he hadn't personally stress-tested. When Claflin first sketched his idea, a T-34 turret bolted to a flatbed rail car, Norwood looked at the drawing for a long time and then said simply, "The recoil will flip it." He was right. A 76mm F-34 cannon generates 38,000 Newton-meters of recoil force at the moment of firing. A 12-ton flatbed car sitting on standard rail has no lateral mass to absorb that. By every calculation Norwood could run in his head, the first shot would send the car off the track. By every calculation, except one. Brian Woods, Claflin's railmaster, a lean man who spoke mostly to the track itself, pressing his palm flat against the steel to feel vibrations the way a doctor presses a stethoscope to a chest, had spent 3 years running maintenance trains on the Novelski siding. He knew something about this particular rail that no manual recorded. A 200-meter stretch on the approach to the forest bend ran at a 3-degree downhill grade. The rail tension there was 40% higher than standard spec because a 1941 repair crew had over-tightened the fishplate bolts in a winter storm and never corrected it. High-tension rail, downhill grade. A flat car with its center of gravity kept deliberately low. Wood sketched it out in grease pencil on the back of a ration box. Norwood stared at it. Then Norwood took the pencil and made 3 changes to the pedestal mounting angle. "It won't flip," Norwood said. "The rail absorbs it." They had no authorization. They had no orders. They had a ration box, a grease pencil, and 17 dead tanks with live stings. They started work that night. If you want to see more of stories like this, please hit that like button and subscribe. It helps us share more forgotten stories from World War II. The orders arrived on a single sheet of paper, stamped in red, folded once. No envelope. Colonel Petrov's aide had slid it under the door of Claflin's bunk at Smolensk Forward Station like a man delivering an eviction notice. Rail security detail. Nevelsky Depot. Report 6 o'clock, November 1st. There was no explanation. There didn't need to be. In the Red Army's armored branch, a tank commander without confirmed kills after 14 patrols didn't get explanations. He got rail security. He got Nevelsky, a depot so far behind the line that the men stationed there called it the waiting room, because the only thing that happened there was waiting to be forgotten. Claflin was 29 years old. He had a tanker's build, broad through the shoulders. He's shorter than he looked on paper, and a tanker's habit of measuring everything in angles and distances, the way a carpenter can't stop seeing the geometry in a room. He wore his padded olive-drab coat, buttoned to the throat against the November cold, and his grease-stained tanker's helmet was pushed back on his head at the angle of a man who had stopped caring what he looked like to his superiors approximately 6 patrols ago. His expression, when he stepped off the supply truck at Nevelsky at 5:52, was not defeat. It was something more controlled than that. It was the face of a man filing information away, calculating, waiting for the equation to change. What he saw at Nevelsky did not immediately suggest the equation was about to change. The depot was a secondary rail junction, 4 tracks wide, bracketed on both sides by Siberian pine forest, so dense the trees seemed to lean over the yard like spectators. A wooden operations hut, a fuel store, a water tower with a crack running its full height, patched 3 times with sheet steel and rivets. 4 men standing at loose attention near the hut. His crew, assembled by someone who had clearly grabbed whoever was available and pointed them east. A radio operator named Dushkin, who looked about 19. A logistics corporal. And 2 men he had never met. A lean, quiet figure crouching at the edge of the nearest track, with one palm pressed flat against the rail, and a square-shouldered mechanic in a leather apron who was watching Claflin approach with the evaluating squint of a man deciding whether a new piece of equipment was worth his time. And the man with his hand on the rail was Brian Woods. The man with the squint was Hagler Norwood. Claflin noted them both, said nothing, and walked the length of the yard first, because that was what you did when command dropped you somewhere without a briefing. You walked it. You measured it. You let the place tell you what it was. What the place told him at the far end of the 4th track was something he hadn't expected. The T-34s were arranged in no particular order, which told him everything about how they had arrived, hauled back from forward positions in whatever sequence the recovery teams had managed, under fire, in the dark, and left where the tow cables gave out. 17 of them. Some had burned, the steel around their hatches still faintly stained with the brown shadow of old smoke. Some had simply stopped. Engines seized. Transmissions shattered, running gear torn off in minefields. 2 had taken direct penetrating hits from 88mm guns, and those 2 were the worst to look at, the turrets shifted off-center on their rings as though the tanks had been picked up and dropped. Claflin walked between them slowly, the frost crunching under his boots. The Red Army's process for writing off a tank was efficient. Recovery teams stripped the components with resale value. Optics, radio sets, engine parts were retrievable, and filed the rest as non-recoverable. Paperwork went up the chain. The hulls were logged as scrap. Novelski's yard had clearly been the end point of that process for several months, because nobody had gotten around to the next step, which was cutting the hulls apart for raw steel. The hulls just sat there, and because nobody had gotten around to cutting them apart, the turrets were still attached. Claflin stopped in front of the third tank in the row. The hull was a write-off. The entire lower chassis had been caved in on the left side, the tracks long since stripped. But the turret sat level and intact on its ring. The 76mm F-34 gun extended forward at a slight depression angle, as though the tank had died mid-aim. Claflin walked around it slowly, then put both hands on the barrel, something you were absolutely not supposed to do, and tested the elevation mechanism. It moved. Stiff, but it moved. He stood there for a moment doing the arithmetic he always did. The F-34 could fire a high explosive round at 680 meters per second. Effective combat range against light armor, 800 meters, against a half-track. Not at any range that mattered in forest terrain. It was not a question of effectiveness. It was a question of geometry. One round, one result. 17 turrets, 17 guns. All of them dead only in the sense that the machines beneath them couldn't move anymore. He looked down the row. 17 dead tanks, 17 live stings. Then he turned and walked back toward Norwood, who had not moved from his spot near the operations hut and was still watching him with that evaluating squint. "How many of the turret rings are functional?" Claflin asked. Norwood thought about it for exactly 2 seconds. 12. Maybe 14 if I clean the traversal gears on the ones that took fire damage. And the guns themselves. All 17 are mechanically sound. I already checked. He said it without emphasis, or the way a man states a fact he recorded weeks ago and has simply been waiting for someone to ask about. Claflin looked at the flatbed rail cars on the maintenance siding. 3 of them, low profile, wooden-decked, iron-framed. 6 meters long, rated for 12 tons. A T-34 turret weighed just under 2 tons. He looked at Norwood. "I need to know if we can mount one of those turrets on a flat car." Norwood's squint didn't change. "The recoil will flip it." "I know," Claflin said. "Tell me why." That conversation lasted 4 hours and moved progressively from the operations hut to the yard to the rail siding and back again, with Norwood doing most of the talking and Claflin doing most of the listening and Brian Woods joining somewhere in the second hour. I'd drawn over from the tracks by the specific gravity of 2 men arguing about a problem he recognized. Woods was the quietest of the 3. He communicated primarily through gesture and the occasional short declarative sentence that landed with the weight of a much longer argument. He had been running maintenance trains on the Novelski siding for 2 years, which meant he knew every meter of it the way a riverboat pilot knows a stretch of water, not from maps, but from memory and feel. He knew where the rail tension was high and where it went soft. He knew the grades. He knew which sections of track had been repaired in haste and which had been properly ballasted. When Norwood finished explaining the recoil problem, the 38,000 Newton meters of force, the lateral instability of a flat car with no counterweight, in the near certainty of derailment on the first shot. Woods had been quiet for a moment. Then he crouched down and pressed his palm to the rail they were standing beside. "Not here," he said, "but 200 meters north. The approach to the forest bend. The crew that patched the rail there in 41 over-tightened the fish plates, never got corrected." He stood up. "Rail tension is about 40% above spec on that stretch, and it runs downhill at 3 degrees for the full 200 meters. Norwood looked at him. "How much does that change the lateral load transfer?" Woods did the calculation in his head, or somewhere inside him that wasn't quite his head, the part of a man that knows a thing through 10,000 hours of contact rather than through formula. "Enough," he said. Norwood pulled out the only thing available to write on, and which was the back of a wax paper ration box and a grease pencil from his apron pocket. He drew the flat car in cross-section, then the turret ring, then the pedestal mount, the bracket that would connect one to the other. And as he drew it, he began talking through the problem in the way mechanics think, out loud and iteratively, each line on the paper a proposal and a question simultaneously. The standard approach would center the turret mast directly over the car's midpoint. That was wrong for this application. If the pedestal was angled forward 3 degrees, just 3, and the mounting bolts were distributed asymmetrically, weighting toward the front axle of the car, the recoil force would push down and forward rather than laterally. On a standard rail, it still wasn't enough. But on a section with 40% above spec tension, running downhill, the rail itself would act as a brace. The energy would transfer into the track rather than into the car's tendency to tip. He made 3 changes to the pedestal angle with the grease pencil. Then he looked at it for a long time. "It won't flip," he said. Woods looked at the drawing, nodded once. Claflin looked at both of them. "Who authorized this depot?" he asked. "You did," Norwood said, without looking up from the ration box. "Just now." They started that night. Not because there was urgency yet. The German column wasn't moving for another 72 hours, though they didn't know that. But because the kind of work Norwood was proposing didn't survive exposure to daylight and passing officers. It was the sort of project that existed in the gap between what was written in orders and what was actually possible. And that gap was only navigable in darkness, by men who had already decided the paperwork could be sorted out later. Callahan George appeared at the yard at 2100, summoned by Norwood through some mechanic's telegraph that Claflin didn't fully understand. George was the youngest of them, 22, heavy through the forearms from years of loading work, with the slightly flattened nose of a man who had walked into low hatches one too many times. He was the loader, which meant he understood confined spaces and weights and the specific mathematics of fitting large objects through small openings. He looked at the turret they had selected, the third one in the row, the one with the fully functional traversal ring, and assessed it the way he assessed everything, in terms of how long it was going to take and how much it was going to hurt. 8 hours, he said. Maybe 10. 6, Norwood said. George looked at the manual chain hoist Norwood had produced from the maintenance shed, then at the turret, then back at Norwood. 8, he said, and went to get the chains. The work was cold and loud in a suppressed way, the sound of manual drills biting into steel, of chain mechanisms ratcheting under load, of men speaking to each other in the shorthand of shared physical effort. Norwood had fabricated the pedestal mount from 2 sections of salvaged I-beam and a bolt pattern he had marked with a center punch on the flat car's frame that afternoon. And the welds were done with a field kit running off a battery truck, and they were not pretty. They were the welds of a man who cared about structural integrity and nothing else, thick and slightly irregular, the kind that would hold through violence because they were built with violence in mind. The turret ring came off the hull with more resistance than expected. The traversal gear housing had warped slightly in the cold, and for 40 minutes in the middle of the second hour, it seemed possible that none of this was going to work. Norwood said nothing during those 40 minutes. He simply kept working, adjusting, applying heat with a torch where the metal had contracted, testing the seating, adjusting again. The temperature at midnight was -14. The fog had come in from the north and was sitting in the yard like a presence, the dampening sound, turning the work lights into soft orange smears. At 3:15, the turret seated onto the pedestal ring. Norwood tested the traversal. It moved through a full 360 degrees, slightly stiff but functional. He tested the elevation. It moved. He stood back and looked at what they had built. The flatbed car with the T-34 turret mounted on its deck was, by any reasonable measure, an absurd machine. It was low and small and rode on wheels sized for cargo, not combat. The 76mm gun barrel extended forward beyond the front of the car by nearly 1.5 meters. giving the whole assembly a front-heavy, insect-like quality in the fog. It looked improvised because it was improvised. It looked crude because it had been designed in grease pencil on a ration box by a man who trusted tension mathematics over formal engineering approval. See, Claflin stood at the far end of the siding and looked at it for a long time. Then he looked at the forest on both sides of the rail line, the dense Siberian pines disappearing into the fog, the darkness between the trees absolute, the tracks running north toward the forest bend, where Brian Woods had told him the rail tension was 40% above spec on a 3-degree downhill grade. He thought about German patrol leaders standing in that darkness, hearing the clack-clack of a rail car in the fog, looking for a locomotive that wasn't there, looking for something large enough to threaten them, a proper armored train, something that matched the scale of the noise they were hearing, not seeing a tiny, low-profile flat car with a dead tank's turret bolted to its deck, coasting silent and greased down a 3-degree slope in the pre-dawn dark. Not seeing it at all. Not until the gun fired. The first test happened at 4:30 the same morning, before the light came up, because Woods insisted the grade had to be run in conditions as close to operational as possible, and operational meant darkness and cold and fog. There was no argument about this. Everyone understood it without discussing it. Woods had spent an hour applying the grease, a specific mixture he had been using on Novelsky's maintenance cars since 1941. Heavier than standard rail lubricant, mixed with a small amount of rendered animal fat that he had never explained to anyone and nobody had ever asked about. He applied it to a 60-meter section of track on the northern approach with the focused attention of a man preparing an instrument, coating each rail in a thin, even layer that caught the work lantern light and turned the steel a dull amber. Then he released the handbrake. The car moved. It moved slowly at first, almost imperceptibly, the way a very large object begins to move when the force holding it finally gives way. Not all at once, but in a kind of settling, a decision made by weight and gravity working together over the 3-degree incline. Then it found its pace. The wheels turned on the greased rail with almost no sound. The clack-clack of the fishplate joints was there, but reduced, a rhythm rather than a noise, distant and soft in the fog, the kind of sound that could travel 200 meters through pine forest and arrive at a human ear as something not quite identifiable. Not a train, not machinery, something in between. Claflin stood at the bottom of the incline and watched it come. At operational speed, which Woods had calculated at approximately 18 kilometers per hour on this grade, assuming full grease application and still air. The car was almost invisible in the fog until it was 40 meters out. The turret emerged first, the long barrel materializing from the white darkness like a pointing finger. Then the flat car body, low and dark, riding the rails with a smoothness that had nothing to do with engine power and everything to do with gravity and geometry. Woods brought it to a stop with the handbrake at the bottom of the incline. The whole run had taken under 90 seconds. Nobody said anything for a moment. Then Norwood walked over and crouched beside the front axle, checking the wheel flanges where they met the rail, and looking for any sign of lateral displacement. He checked the pedestal bolts. He checked the traversal ring seating. He stood up, wiped his hands on his apron, and said, "Again." They ran it 4 more times before dawn. Each run, Woods adjusted the grease application slightly. Each run, Claflin stood at the bottom and timed the approach by sound. The moment the car became audible against the background noise of the forest. The moment it became visible in the fog. By the 4th run, he had the numbers he needed. In standard fog conditions on the Novelsky northern approach, the car became audible at approximately 110 meters and visible at approximately 35 meters. At 18 kilometers per hour, the time between audible and visible was under 9 seconds. 9 seconds was not enough time to identify a threat, acquire a firing solution, bid and engage. Not for a patrol that wasn't expecting armor, not in the dark, not in fog this thick. Claflin walked back to the operations hut, sat down at the table, and began working out the mathematics of the ambush. Harold Mitchell arrived 2 days later on a supply truck from the 17th Mechanized, carrying his kit, a letter from his wife, and a reputation as the steadiest gun hand in a regiment that no longer had any guns worth steadying. He was 31, built like a man, designed specifically to fit inside a T-34 turret, compact, economical in his movements, with the particular patience of someone who had spent years in confined metal spaces, waiting for the right moment to do a violent thing. He had 17 confirmed kills in a T-34 before his tank was destroyed at Kursk in July. Since then, he had been attached to a supply column, because the Army had no tank to give him and no better use for a gunner without a gun. When Norwood showed him the flat car, Mitchell walked around it twice without speaking. He climbed up onto the deck, lowered himself into the turret, checked the breech mechanism, traversed the gun through a full rotation, checked the elevation. He came back up. "What's the recoil feel like?" he asked. "We haven't fired it yet," Norwood said. Mitchell looked at him. "When?" "Tomorrow," Claflin said. "Tonight you learn the track." That night, Mitchell ran the gravity approach 6 times with Woods, each time from inside the turret, learning the vibration of the car through the metal around him, the way the fishplate joints registered as a pulse through the traversal ring, the way the car's subtle left lean on the 4th section of track ahead of the forest bend would affect his aim if he didn't compensate. He was doing what every good gunner does before a shot, building a physical map of the platform he was shooting from, because the platform was never stationary and the gun was never truly level, and every variable was something you either measured in advance or absorbed as error. The live fire test happened the following morning at 5 o'clock, aimed into the pine forest on the eastern side of the track, at a target Norwood had assembled from salvaged hull plate, a steel rectangle roughly the dimensions of a half-track's forward compartment, propped against a fallen tree at 200 meters. Mitchell fired once. The recoil hit the car like a fist. The whole flat car frame compressed downward. Not a flip, not a tip, but a hard vertical press into the rail that Claflin felt in his feet from 20 meters away. The high-tension rail absorbed it exactly as Norwood's ration box calculation had predicted, channeling the force down and forward into the track bed rather than laterally into a rollover. The car rocked once and steadied. The hull plate at 200 meters had a 76-millimeter hole through its center. Norwood checked the pedestal bolts. All holding. Traversal ring undamaged. He looked at Mitchell. Mitchell was already reloading. He fired twice more. The car rocked and steadied each time like a boxer absorbing a body shot and returning to stance. The target at 200 meters ceased to be a recognizable shape. Nobody cheered. They weren't that kind of crew. Norwood made a note on a new ration box. Woods checked the wheel flanges. Mitchell climbed out of the turret and helped Callahan George stow the remaining shells in the car's ammunition rack. A wooden frame bolted inside the turret ring housing, shaped to hold 24 rounds in a horseshoe pattern that George could access in full rotation without changing position. 8 seconds per reload. They had timed it. 3 days later, the German column moved. The intelligence came from a partisan relay at 2300 on November 9th. A Jagdkommando unit, designation Siegfried IV, moving along the forest road parallel to the Novelski rail line with the objective of hitting the junction at the forest bend. 3 SDKFZ 251 half-tracks, 1 Panzer IV providing overwatch from the road high point, and an infantry element of approximately 40 men. The junction they were targeting was the only switch point connecting the Novelski secondary line to the main supply artery. If Siegfried IV destroyed it, 3 Soviet rifle divisions currently holding a 40-kilometer front would be cut off from resupply within 72 hours. Claflin looked at his map for a long time. Then he looked at the track. The forest bend was exactly 200 meters north of where the high-tension rail section ended, which meant the gravity run would put the car into firing position with approximately 9 seconds of warning to anyone waiting at the bend. And the Panzer IV on the road high point was the problem. It had a clear line of sight down the main road, but the forest between the road and the rail line was thick enough that it couldn't engage the rail car directly unless the car was sitting stationary in the open. The car would not be sitting stationary. That was the point. They moved into position at 3:30. No engine, no lights, the car pushed by hand to the top of the incline, then held by the handbrake while Mitchell lowered himself into the turret and George followed him down with the first shell already in hand. Claflin stood on the rear of the car in the turret hatch position, his grease-stained helmet pulled low, scanning the fog for the geometry he'd been calculating for 3 days. Norwood and Woods and Dushkin were in the tree line with the radio and the handbrake release cable. A simple arrangement, a wire running 20 meters through the pines because nobody needed to be on the car when the brake came off. At 4:17, they heard the column. The half-tracks first, the distinct grumble of Maybach engines running at low throttle on the forest road, moving parallel to the rail line, the sound deadened by the trees and the fog but present, directional, close enough. Claflin pulled the release wire signal. In the tree line, Woods released the handbrake. The car moved. It found its pace in the first 30 meters, quiet, greased, riding the 3-degree grade with the same unhurried momentum as every test run, that the turret emerging from the fog at the bottom of the incline like something the forest had produced rather than something built by men with manual drills and a ration box. Mitchell was at the gun. George had the second shell ready. The lead half-track was at the bend when the car reached firing position. Mitchell fired. The muzzle flash was the only light in the forest for half a kilometer in every direction, a hard white crack that seemed to tear the fog apart at the seam. The high-explosive round covered 200 meters in under 0.3 seconds. The half-track's forward compartment ceased to exist in a way that was not gradual. The vehicle stopped. The car was already moving again. Woods had let the grade carry it forward another 40 meters, which changed the angle by 11 degrees. Mitchell traversed. George reloaded in 8 seconds. And the second half-track was turning when the second round hit it. The German infantry broke for the tree line. The Panzer IV on the road high point fired blind into the fog twice, both rounds passing well over the rail line, because the crew was aiming for a locomotive that wasn't there and a profile that was twice the height of what they were actually shooting at. By the time the third shot came, the car had drifted another 30 meters forward and the muzzle angle had changed again, and the Panzer IV round hit nothing but pine trees and frost. Mitchell fired a third time, the third half-track. Then Woods applied the field brake, a drag mechanism of Norwood's construction, a steel plate on a lever that bit into the rail, and the car slowed and stopped in the fog, invisible, stationary, quiet. And the German infantry was shouting in the trees. The Panzer IV had stopped firing because it had no target. The forest bend smelled of cordite and burning metal and Siberian pine. The entire engagement had lasted 4 minutes and 11 seconds. Claflin stood in the tree line with his hand on the radio and did not transmit anything for a long moment. He was counting. 2 confirmed kills on the half-tracks. The third was burning. The Panzer IV was still out there, but the junction was intact, and Siegfried IV had no infantry left in any condition to assault it on foot. The German after-action report, recovered 6 weeks later from a field headquarters outside Vitebsk, described the engagement at the forest bend in terms that Norwood found quietly satisfying when the translation reached Novelsky. Now, the report noted that Soviet forces had employed an unknown weapons platform operating on the rail line, something low profile, apparently without a conventional locomotive, capable of firing from positions that offered no visible profile and then disappearing before a counter-fire solution could be established. The report used the phrase Stahlgeister, steel ghosts, and requested urgent intelligence on Soviet rail-mounted armor development. There was no Soviet rail-mounted armor development to report. There was a flatbed car, a salvaged turret, a ration box design, and 4 men who had worked through a November night with manual drills and chain hoists because nobody had told them the mathematics didn't work. The Germans sent 3 separate reconnaissance patrols over the following 2 weeks to locate the locomotive. And they found no locomotive. They found grease marks on a 60-meter stretch of rail and a bolt pattern on a flat car that had already been moved back into the maintenance siding and covered with a tarpaulin. The second engagement, at a road crossing 8 kilometers north of Novelsky, lasted 6 minutes. Mitchell fired 11 rounds. Norwood had by then fabricated a second pedestal mount from the same I-beam stock, and a second turret, the 9th in the row, with the cleanest traversal ring, had been seated on a second flat car. 2 cars now operating in sequence, each one silent on its own greased grade, each one arriving from a different angle. The German patrol at the road crossing reported being engaged by at least 6 armored vehicles operating on parallel rail lines. There were 2 flatbed cars, 2 guns, and 5 men, and the Iron Throat engagement happened on December 2nd. The junction was a critical switching point designated on Soviet maps as Novelsky Central, called the Iron Throat by the repair crews who worked it because everything the 3 rifle divisions needed passed through it, and because the throat of a thing is what you cut when you want to kill it quickly. The German column assigned to cut it was not a patrol. It was a column. 4 Panzer IVs, 2 Tiger Is in overwatch position on the road embankment, and a motorized infantry company. The intelligence on this reached Claflin at 2200. He had until approximately 4 o'clock. He had 2 flat cars, 31 rounds of 76mm ammunition, and 6 hours. But what followed was the engagement that German survivors would eventually report in enough detail that the phrase Stahlgeister moved from a single field report into regular communications traffic. Mitchell operated the primary car, George loading in 8-second intervals, running the gravity approach 4 separate times from 4 different positions on the Novelsky network, each time from a different spur, each time at a different angle, using the track layout the way Claflin had spent 3 days mapping it, turning the junction's complexity from a vulnerability into a maze. The second car, operated by Norwood himself on that night, handled the Tiger overwatch problem by approaching from the eastern spur at a lower angle that put the embankment between the car and the Tiger's direct fire. Norwood was not a gunner, and he was a mechanic who understood precisely what the gun could do at each elevation setting because he had built the mounting that made elevation possible. He fired 7 rounds in 11 minutes, all on the embankment face, not expecting to defeat Tiger armor, but understanding that a Tiger crew buttoned up against high explosive fire on their glacis plate is a Tiger crew not acquiring targets below them. In 12 minutes of combined engagement, the 2 cars fired 30 rounds. 3 Panzers destroyed. The Tiger pair withdrew to the road, rather than advance blind against a weapons platform that moved and offered no consistent firing signature. The Iron Throat held. Claflin sat on the deck of the primary flat car afterward, in the dark and the cold and the cordite fog, and did not feel the thing he had expected to feel. But he felt the mathematics of it instead, the specific numbers of what had happened, the margins by which it had worked, the places where it could have gone differently. Norwood was already checking the pedestal bolts by touch in the dark. Woods was on the rail, palm down, reading the track. The junction behind them was intact. Supply trains would move through it at dawn. The official recognition came slowly, the way official recognition always does when the thing being recognized was unauthorized to begin with. The endorsement arrived in February, routed through channels that had spent 3 months deciding whether Claflin's command had acted brilliantly or simply gotten away with something. The distinction mattered to the men filing the paperwork. It mattered considerably less to the 3 rifle divisions that had received uninterrupted supply through December and January. The technical documentation, Norwood's ration box drawings, transferred to proper engineering paper by a draftsman who asked no questions about the original medium. reached the Navy's Bureau of Ordnance in March through a liaison officer who had read the Novelski engagement reports and recognized something in the pedestal mount design that had applications beyond the Eastern Front. The principle of using a rail's own structural tension to absorb weapons recoil was formally studied, tested, and eventually incorporated into a provisional doctrine on rail-mounted direct-fire support that the Bureau designated in the dry language of official documents as the Mobile Rail Gunboat Program. And Norwood read about it in a summary report 6 months later and said nothing. He was already working on a third pedestal mount, this one designed for a wider car with a heavier rail rating, the grease pencil moving across the back of a new ration box with the same unhurried precision as the first time. Claflin had 14 patrols and 0 confirmed kills when he arrived at Novelski. He left it with a different kind of accounting, one measured not in confirmed kills, but in junction switches held, supply lines maintained, and the specific gap in German intelligence reports where a locomotive should have been and wasn't. The steel ghosts moved in fog and gravity and silence. The enemy looked for an engine. There was no engine to find. The most dangerous weapon, in the end, was the one they never saw coming. If you want to see more of stories like this, please hit the like button and subscribe. It helps us share more forgotten stories from World War II and comment where you're watching from.